So let's just talk about the merge sorting algorithm. So the merge sort is a divide and conquer sorting algorithm. That means in this algorithm, first of all, we divide the array into two halves recursively, and then we sort each of the halves. And thirdly, we merge all the sorted halves back together. So in merge sort, we just follow these simple steps. So like an example, suppose we have the values like 3, 2, 1 and 5. Now to sort them, first of all, we have to divide them recursively into two halves. So let's just divide them into two halves. So here in the first half, we're going to have 3 and 2. And in the second half, we're going to have 1 and 5. So again, we have to divide them into sub-arrays. So this will have 3 and this will have 2. Similarly, this will also be divided. So here we're going to have 1 and then we're going to have this 5. So we have to keep divide them into two halves until we have only single elements. So single elements means they are sorted. So now all you have to do is we have to sort them, sort each of the halves, and then we have to merge them back together. So that means here we're gonna merge these two subarrays. So 2 and 3 will be sorted and merged. Similarly, they will also be merged together. So 1 and 5 will be sorted and merged. And finally, we have to merge and sort these two arrays. So here we're gonna have 1, 2, 3 and 5. And you can see our array is sorted. So this is the final output of the merge sort. So first of all, we call the merge sort function recursively. We divide the array into two halves recursively until there is only one element in the array. And after that, we call the merge function, and the merge function merges the sorted halves back together. And this way we get this sorted final output. So let's just calculate the time complexity of the merge sort. So first of all, we divide the array into two halves recursively at each step until we have single elements. So because the array is divided at each level until we have single elements, so that means here n by 2 raised to the power k will be 1. So that means we can get the value of k, which will be log n base 2. So this is the complexity for the division. So because after that each element is sorted and merged back together, so this takes on time at each level. So that means the overall complexity that we're gonna have is order of n log n. And this will be our best case, worst case, and the average case complexity. So the merge sort is extremely efficient sorting algorithm. Here it guarantees that time complexity will be O of log n at each cases. So unlike the quick sort, here we have n square complexity in case of worst case. Now here this is one stable sorting algorithm. That means the equal elements will preserve its order. So linked list can be used for the merge sort because here we do not require any kind of random access. But the only drawback with the merge sort is that it requires extra memory. So this is not one in-place sorting algorithm like the quick sort. Here we require extra memory. So here we have the space complexity of On. So hope you understand about this merge sorting algorithm. In the next video, we're gonna explain the code of the merge sort. So that's it for the video. See you in the next one. Take care.